Hello, everybody. Today I want to teach you about using measures of center to compare two data sets. So if you will, please make this the title of the next free page in your math notebook. And when you have done so, close it up and give me your concentration. All right, so we have reviewed, and in sixth grade you learned different ways to look at sets of information, which we often call data sets. So like this is a data set showing when people ordered paint, how much paint did they order? 5 people ordered 1 gallon, 3 people ordered 2, and so on and so forth. And so to answer a question like, how much paint do people order? Something like that. It's very strange when they ordered different amounts of paint. And so we called that a statistical question when you have lots of different answers to the same question, and we learned some methods for answering statistical questions last year. We either looked at measures of center or measures of variability to see how to answer those. So ones I want to review real fast for today are measures of center real quick. So to find the mean, you add up all the different answers to the question and divide by how many there were. So in this particular case, the mean for the amount of paint is 1 plus 1 plus 1 plus 1 plus 1 for the ones, that's 5, plus 3 twos, 2 plus 2 plus 2, plus 1 4, plus 2 5s, plus a 6, plus a 7, plus a 10. And then I divide by how many numbers I added. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14. So all in all, they ordered 48 gallons and 14 people bought it. So when I divide that, we would say the mean was about 3 43/100, let's say, gallons. Call that a mean. Sometimes people call that an average as well. The median is the number in the middle if the numbers are ordered from least to greatest. So in this case, if I had a list of these amounts of paint, there was 1 5 times, 1 1 1 1 1, 3 twos, a 4, 2 5s, a 6, a 7, and a 10. And we want the number exactly in the middle. So I remember there were 14 of them when I did the mean. So 1, 2, 3, 4, 5, 6, 7's probably it. So the median's probably around here. Let's see, if I do that, there's 1, 2, 3, 4, 5, 6, 7 here. 2, 3, 4, 5, 6, 7 here. So since it's in between two numbers, the median, if I put the middle right here, it's 7 and 7. And so it would be the number halfway between these two right here, which halfway between 2 and 2 is still 2. So the median number is still 2 gallons. And the mode is just the number that happens the most times. In this case is 1. We also learned how to calculate range, quartiles, and interquartile range in 6th grade. Those will be coming up later, but I don't want to touch on those today. So let's look at something like this. What if we had two sets of data for the same question? So this says 7th graders from a middle school were asked how many hours they spend on homework per week. Their data is in the red. 10th graders were also asked how many hours they spend on homework per week. Which students spend more time doing homework? Well, hard to tell. Right off the bat, I see like the 7th graders, the person who did the most does the most, but also the person who does the least, and there's a whole bunch in the middle. And so it's hard to say which one does more and which one does less because it looks pretty close. So a way we're going to do that, we're going to calculate those measures of center, the mean, the median, and the mode for each, and we're just going to see how it looks for 7th graders and then also for 10th graders. So let's start with mean. I don't want to make you watch me calculate these means if you don't want to. This is, it's just a matter of calculating. Remember, mean, you add up all the different values and then divide by how many there were. So let's see how many people were asked. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21 here. And 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 21. So 21 in both cases. So what I'm going to do, I'm going to add up 1 plus 3 plus 4 plus 4 plus 5 plus 6 plus 6 and so on divide by 21, and then do the same thing here. I'm just going to go ahead and pause and do that so you don't have to watch me calculate the mean a bunch of times. If you want to pause and calculate the means too for practice, if you haven't done that in a while and need the practice, that would be great. And then you can compare to what I get. I'm going to pause, and then when I unpause, I'll have calculated them. I calculated them, and they are close. But it looks like the mean for the 10th graders is slightly higher if I calculated them right. I had to do it a few times, so I may have made a mistake, but I think I got them. So this means, remember what a mean is. A mean means on average. So on average, so far, it looks like 10th graders spend a bit more time. Let's go to median. So median's the number in the middle. So that means like whatever number the median is, half spend less time than that and half spend more time than that. That's what it means. It kind of tells you right in the middle. So if there's 21 numbers, I believe the 11th number will put 10 on this side and 10 on this side for the median. So I'm going to find the 11th number, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. So the 11th number here is 7. So basically that means half of the 7th graders spend 7 or more hours on their homework. Half of the 7th graders spend 7 or less hours. Down here, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Same thing. The median number for the 10th graders is 7 as well. So the medians match. No difference there. And then the mode, remember, that's the number that happens the most time. So when we talk about it, we would say something like, more students spend 7 hours doing homework than any other amount. So that's 3 different ways to answer the question. You know, who spends more time on average, whose median is higher, half spend more, half spend less. You know, whose mode is higher, that's, you know, the time spent more than any other time. So it looks like here these are very, 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 very close. But due to a slightly higher average, I would say the 10th graders spend more time on average. Just a bit. Looks like 3/10 of an hour. That's like 18 minutes, something like that. All right. Before we get to doing one together, I want to show you sometimes you don't really need to do much math to answer the question. So if you look here, the line plot below shows the height of players on the women's gymnastics team versus the men's volleyball team. Which team has taller players? In this case, when you look at it, it's fairly obvious sometimes the answer to the question. In this case, obviously the men's volleyball team, all the players are taller than the tallest woman on the gymnastics team. So sometimes you can just do it like that and you can just answer visually. And I just want to point that as well. It needs to be very, very obvious. You shouldn't do that if there's any uncertainty at all, but sometimes it's just extremely clear, and that's okay to say too. All right, let's do one together. Open your notebook and pause and write this down. We're going to talk about whether the teachers or siblings who responded to this survey, teachers or students rather, have more siblings. And if you want to write this as well, we're going to compare them by mean, median, and mode. So we're going to look at teachers and we're going to look at students. So go ahead and pause now, or write that down and unpause when you're ready to go. All right, let's start with mean. See how many there are. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20. 1, 2, 3, 4, 5, 6, 7. Right, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, also 20. Got to make sure. You never know, they could have been different, but they aren't. So let's start with mean. The mean is 0 plus 0 plus 0 plus 1 plus 1 plus 1 plus 3. 4 2s will make 8 plus 3 3s will make 9 plus 2 4s will make 8 plus 3 5s will make 15 plus a 6 plus a 9. 58 total siblings divided by 20. Looks like the teachers have an average of 2 9/10 of a sibling, just about 3. It's the average there. And let's go to the student 0. 2 1s will make 2. 4 2s will make 8. 2, 3, 4, 5 3s will make 15. 4 4s will make 16. And a 5 and 2 6s and a 7. 65 divided by 20. Looks like they're a bit higher, a little more than 3 siblings. So the students have a higher average. Let's look at median and mode as well. So the median, if there's 20 numbers, it'll be between number 10 and number 11. If we do that, there will be 10 on each side. So let's see, 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11. So it's between 2, this top 2, and this first 3. So halfway between 2 and 3 is, of course, 2.5. So half the teachers have more than 2.5 siblings, which is 3 or more. Half have less than 2.5, which is 2 or less. Let's go down here. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, and 11 are both 3s here. So it's halfway between 3 and 3 is 3. So median's a tad higher there, just a tad, because remember our very next number here would have been 3. Here they were both 3. And mode for teachers is 2. And for students is 3. So it looks here like pretty obviously, this is nice when it works out this way. Students were actually higher in all 3 categories. So I think that's a fairly certain answer that students have more. Okay. I'm going to allow you to copy this next one down or not. If you want to pause and finish this one, please do. I do want you to have a reminder whether or not you write it, that sometimes it's fairly obvious and you don't need to do the statistics. So for instance, do students who responded to this survey spend more time exercising or more time playing video games? You'll notice basically here, if we did the work, like almost everybody is 6 or more here. And we're just like all the respondents are as high as these top 4 in this other category. So when you look at this set, I think without even doing the math, you can tell that this is just going to be like a lot higher, a lot more. And that happens sometimes, and that's okay when it's very obvious to say so. You don't always have to like necessarily do the math to figure it out. Okay, y'all? That is how you use measures of center to compare two data sets. How do you know how this went? Well, 1 would be, can you calculate mean, median, and mode for a data set? And 2 would be if you can compare these for 2 data sets to know which had a higher whatever's being measured. If you feel confident in doing these 2 things, you're ready to go. If not, give this another watch, and I think you'll be ready to go after you do. Thank you.